there. Welcome, to section 1.3, data collection and sampling techniques. So think about ways to collect data. I ask, what are some common ways to obtain data? Well, the first thing I think of is 2020 was a census year, right? And they mailed out forms. You could fill out those forms and mail them back. If you didn't want to fill out the form and mail it back, you could go online and fill out a form online. If you may have gotten a knock on your door at some point. They had census people coming door to door and saying, did you fill out the census? So you could do a door-to-door personal interview, conversation with somebody. You could, doesn't relate to the census, but you could just observe. See what's going on, whatever it is that you're looking for. You obviously need to know what that is, but you could do some observations. You could do also, which I think is different from an online form, you could do an online survey. I feel like a form, if somebody was directed to go to that, a survey might be a little bit more open, like, oh, I stumbled across this, I'm going to try it. So there's a lot of ways to obtain data, and then you have to figure out who are you going to go to? Whose doors are you going to knock on? Who are you going to observe? Who are you going to send an email to? All those kinds of things. So the first thing, like we've mentioned before, you want to always avoid a biased sample. Some kind of error has been made in selection for your sample. So you'd have a sampling error. That's a problem. We have a biased sample. It doesn't represent our population, and therefore our data really probably isn't that good. And statisticians use 4 basic sampling methods to avoid bias as much as possible. So remember, when you've got a biased sample, your sample doesn't represent the population. We probably have some idea of what it's supposed to look like. If we have something off, we can then test that later. So the first type of sample is a random sample. It is exactly what it sounds like. It's a random sample. It uses chance methods or random numbers. And all members of a population have an equal chance of being selected. The biggest thing, since we're talking school here, that I think is teachers, right? When teachers want to call on students, what do? They take a note card or a popsicle sticks to call on a student. So teachers use probably note cards for high schoolers and popsicle sticks for elementary. Popsicle sticks. So it's random. They just draw one out of there. They're not purposely picking on one person, I promise. Another random sample is put everybody's name in a hat and draw it out like a lottery. The first 3 people are who we're going to ask this question, or whatever it might be. Another way, a more technical way than the first 2, is a random number generator. There is actually a random.org out there. It's a lot of words for this part over here on the right-hand side. It says true random number generator. Notice I've got a min of 1 and a max of 100. So anywhere, a number to be chosen between 1 and 100. So I can generate a number, and 74 is my first random number. 49 is my next random number, and 28 if I'm picking the first 3 items. Now that means I have to have items numbered, right? I'm going to do a quick change to 10, and I'm going to generate a random number there. My number generated between 1 and 10 is 2. We're going to need that for the next thing that we talk about, so remember that. So random sampling is just a random sample. We do have a random number generator on the TI-84s. When we have time in class, we will definitely talk about that. It's an interesting situation. It's not hard to use. You just got to know where to put things. And we'll talk about if it's a legitimate random number generator when we go. We'll do a little test and see how that goes. There's also a random number table. They're out there everywhere if you Googled it. But this directions, this is on page 13, by the way, in your textbook. And it says use the random number table to select 10 objects from a population of 85. So I'm going to number everything from 1 to 85, and then I'm going to totally old school this. And I'm going to close my eyes. My eyes are closed right now. And I am going to just randomly stop somewhere 27 on that table. So 27 would be the first item that I choose. And then I go down the list and I keep picking. So 76, then 33, 31, 73, 30, 62. If I run into a number, like the next one is 99, well, I only have 85 items. So 99 just gets crossed out, and I keep going down the list. So how many do I have? 1, 2, 3, 4, 5, 6, 7, 8. 76 is next on the list, but notice I already had a 76. So that, I can't use it again. 76 has already been chosen. So then I'm going to go to the next one, 55. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 15. I don't think I've got any repeats. If I did, I'd throw it out and go next down the list. If I had something larger than 85, I'd go next off the list. So there's my 10 subjects that I picked from a population of 85. Old school, totally random. Systematic sampling, I was supposed to have those gone, but so systematic sampling is random sampling with a twist. We're going to number each subject of a population, and then we're going to start with a randomly chosen subject and go every kth subject. It seems like a weird word, that kth thing. You'll get it, don't worry. So everything gets numbered, much like the random sample. The only twist to it is that we're going to count out specifically. We're not just going to go right down that random table list. An advantage of this, it is fast and convenient. It's quick. You get this done quickly. Disadvantage, I don't know about you, but sometimes in PE class, the teacher would say we're splitting into two teams. We'll count off 1, 2, and then you'd switch places with someone so you could be on your friend's team. Call it, the PE factor or something like that. So you can manipulate that. That's a disadvantage because then it doesn't become random. And what about if you line up boy, girl, and your K is even, you're going to have teams of only boys and only girls. So there's a couple disadvantages to it. You have to watch out for systematic sampling. So let's do a quick example of what systematic sampling looks like. Suppose there is a list of 350 subjects and you need a sample of 35. So we've got a population of 350, a sample of 35. So what we do is we take the 350 in the population, divide it by our sample size, and that's 10. So our K value is 10. So basically it's spreading out our sample from the whole population. So it says use your calculator to randomly select a number between 1 and 10. What did we have from our random number generator? A 2. So we've got a 2. So what we're going to do, the first subject selected will be 2. So we're going to choose 2. And then we're going to count every kth value. So we're going to count 10 up to item 12. And then up to 22, 32, and on all the way until we hit the end of our sample. That should be a sample, or the end of our population, that should be a sample of 35, evenly spaced. It's all about how you number each one of those subjects. Maybe it's alphabetical, or maybe it's, I don't know, by height or something like that. So that's how you would do a systematic sample. All right, stratified sample. So this one's different. This one, the population is divided into subgroups. They call them strata, according to a relevant characteristic. And then, so let's say in school, let's say we had a already relevant characteristic grade, right? So we've got, oh, I'm sorry, a random sample will be taken from each subgroup. So for example, Marine City High wants to give a student survey. We are going to randomly select 15 students, so maybe we'll do it like a lottery. We'll pick 15 names out of the freshman bin, sophomore, junior, and senior. We have got ourselves a stratified sample. The subgroup is grade. "15 students then are selected from each one of those subgroups. Last but not least is a cluster sample. Cluster sample is a stratified sample with a twist. So this one also is obtained by dividing the population into subgroups or natural groups. They're usually pre-existing, maybe grades at a high school, maybe zip codes, maybe area codes, maybe first hour classes. You're already divided. School makes it really easy for us to have pre-existing groups. In our building, maybe it's seminar, those kinds of things. The clusters are already formed. They're there for us. We don't have to do any work, which makes it really nice and convenient. However, you have to be careful. And then a few of the groups or the clusters are randomly selected, and everyone in the chosen group becomes a subject. So in stratified, we took each one of the groups and we picked a few from each. Cluster, we take all the groups and we just pick a few groups. So for example, let's say we're going to do an East China survey. We're going to go to where each student starts the day. So I'll say first hour, even in elementary, right? You got to go to somebody's classroom. So we're first hour class, and then we're going to pick 2 from each building. So maybe me and Mr. Lehman's class, first hour classes are chosen for this sample. And maybe Mr. Felix and Mrs. McComas are chosen at the middle school. And maybe Mr. Perrin and Mrs. McDonald are chosen at St. Clair High. And maybe, you know, I could go on and on and on. So 2 of those first hour classes from each building, whereas in a stratified sample, I'd pick maybe 5 kids from each class from every single building. There is a little note here on this one. Cluster samples save time and money. Because the clusters are already formed, we don't have to do much work. However, sometimes a cluster doesn't represent the population. Maybe, I don't know, maybe tech kids are all gone, so morning tech kids are all gone, so we lose those people out of our cluster, and that might be an important thing for our survey. So you just have to be careful about what clusters, what you're choosing for your clusters. Probably the least desirable, because it feels the least random. Oh, I went the wrong way. This is in your books, sorry. On page 15, go through and look. It just looks at how the 4 different sampling methods. So here's random, our population are all the cars. We use the table and we've taken 5 of those out for the sample. Systematic, we've chosen every 3rd milk bottle for our sample. Stratified, we've chosen 4 people from each subgroup. To go to our sample. And in cluster, they've got these as area codes, which is kind of a cool idea. They've chosen 2 area codes to be our sample. So take a look at those if that helps to get those straight in your head. There's a couple other ways that we can sample. A convenient sample is exactly what it sounds like. It's convenient. The sample subjects are available or easy to find. A disadvantage is that it's not always random. For example, maybe if you are going to a grocery store at 9:30 in the morning, you might not get a random sample because a lot of people are working at that time, and you probably won't get any kids because they might be, who knows, in school. So you might just get an older population grocery shopping. So is it a good sample? Is it representative of the population? I also said that people leaving voting early in the morning, once you get to vote, you'll see that there's people standing outside asking questions. Does the time of day depend on what kind of voter you might get? Or if you sample people on a subway during rush hour or at 1 a.m., are you going to get a different sample than you might regularly? Volunteer or self-selected sampling. Samples in which the subjects approach the researcher. Excuse me, they want to do this. They want to be in on that sample. So do they have some sort of motive or bias? I think of online stuff. So like Amazon reviews, a lot of times the people who write reviews are unhappy with what they've gotten. So you get, is that a biased sample? Is everybody unhappy? Does that represent the population? Or social media polls, you know, who is you know, your volunteer or your sample person? Sampling error. Oh, I lost my numbers. The difference between your sample results and your population results. So I did a little bit of math. Let me see if I can remember what it was. And I found out that in our school, 261 out of 540 are females. So down here, Moraine City High students, 261 out of 540 are females. That's what it says, females, right? So if you divide that out, I believe that's like 48.3% or something. Feel free to double check me, let me know. Interesting, right? Our population is 48% female, 52% male-ish, right? We round. So those boundaries. A sample of my class. So if I look at my class list, and I did a little bit of adding and subtracting, I did some math, and I found out that I have 33 female students out of my class rosters for statistics out of 51. So notice that comes out to 64.7%. That's a sampling error. For whatever reason, the sample that is my statistics students is not representative of all students based on female or male. So it's a sampling error. There's nothing right or wrong about it. It just is an error. It's the difference between our results from our sample. Our sample is our class compared to the results from our population, the 48.3. We also have a non-sampling error. Non-sampling error doesn't have to do with how you got the sample. It has to do with data. The data are obtained erroneously. There's an error in your data. Probably one of two things. You've got a defective scale of some sort, or an error in recording your data. You missed some numbers, you flip-flopped a couple digits, you wrote things down wrong, you fell asleep halfway through, missed things, whatever it might be. So you've got a non-sampling error compared to a sampling error. I've got a little example here to talk about. We can talk about that at a later time. That should wrap up section 1.3. Thanks so much for sticking through it. Feel free to go through and answer these questions, and we'll talk more. Remember, you can always go back, double check, rewatch parts, listen again, put yourself to sleep. Have a great day. We'll see you guys next time.